Welcome to today's lecture. We're going to be talking about New York City. We're going to be talking about Schelling points. A Schelling point is a selection from a game that, while not mathematically correct, is one that is so powerful and so efficient that people will typically choose it. Let me give you an example. Let's suppose that you and a close friend are traveling to New York City. There's no pandemic. You've agreed that you're going to meet when you arrive, but you haven't given any details to each other. You figure you can take care of that with your cell phones once your planes arrive at whatever airport you're flying into. Now, you could be flying into LaGuardia, you could be flying into JFK, you could be flying into Newark, and then, of course, you have to travel to the city, which is on the island of Manhattan. The weirdest thing happens, law of large numbers. Both of you get on the plane from your various cities and head off to New York. And once the plane is in the air, you realize you've left your cell phone in the airport, and your friend has left the cell phone in the airport as well. So neither of you have your cell phones. You can't borrow a phone to call each other. And you're going to arrive in New York City, and you have no idea where you're going to meet. So what do? You arrive in New York City, what do? Now, you could stay in your airport, but they might be at the other airports. You might decide that you're going to go to the city and pick a random street corner and wait there. Or you could meet at the Statue of Liberty on top of the Empire State Building. And you could pick any place. Where would you pick? Well, the obvious answer is not on a random street corner. There's probably 3, 4, maybe 5 places that most people think of as meeting places in New York City. And it's possible that you and your friend have always talked about spending some time at a particular place in New York City. Maybe it's the Statue of Liberty. Whatever those places are, those are Schelling points. Shortcuts, obvious potential answers. One of the things we like to do is take a look at an example of this. All right, this is the nuclear war game. And in this particular case, we have 2 countries, P1 and P2. They can fight or they can submit. In the case of this particular nuclear war game, country P1 has nuclear weapons and country 2 does not. Now let's look at the payoffs. For example, if they both choose to fight, then country 2's loss is minus 1,000, while country 1's loss is only 6. There's a big difference. However, if they both submit, they have payoffs of 50 and 50, better for both of them. On the other hand, if one of them fights and the other one submits, the payoff's 100 and the other country loses 5. So what are the pure strategy Nash equilibria? Well, if country P2 chooses to fight, P1 should submit because minus 5 is not as bad as minus 6. And if they choose to submit, then they should choose to threaten to fight, and they would get paid 100, which is better than 50. If we go the other way and P1 chooses to fight, then clearly P2 should submit. Minus 5 is not as bad as minus 1,000. And if P1 submits, well then clearly P2 should fight because 100 is better than 50. However, is that what's going to happen? And the answer is no, because the difference between submitting and fighting for player 1 is only 1. And the difference between those choices for player 2 is 100 versus minus 1,000. So this minus 1,000 creates a Schelling point. And what is the Schelling point? It's over here. Because, or here, either one of these two, because player 2 has to avoid this option at all costs. There's too much at risk and they can't afford to do it. So submitting becomes a Schelling point for player 2. So here we are, avoiding nuclear war using game theory by creating a Schelling point. So I will be giving you some examples on the final exam of where you would have to figure out the Schelling point. So learn about this principle and use some of the examples that I've given you. The other thing that I want to talk to you about is from the lecture I gave you the other day, which is the idea of having a conducible good. And so we have a conducible good scenario that I'm going to assign to you as a homework assignment. And in this particular case, I'm going to be putting up a normal form of a game. And this normal form has two married partners and payoffs for being selfish and payoffs for being conducible or working together. What I want you to do is apply what you've learned about pure strategy, Nash equilibria, and mixed strategy, and come up with a solution for this problem. So I want you to find the pure strategy, Nash equilibria, and then I want you to solve it for mixed strategy and tell me what is the optimal mix of behavior in this relationship. And I'll be posting that today, and that's going to be worth 4 points towards your grade. I'm still trying very hard to get this online gaming system to work. The people who developed most of the code and my server company have not gotten together, and so that they're not compatible right now. But I think I'm very close to getting it resolved. If it does, we'll definitely have some games to play over the next week. If not, well, we'll just give you credit for having played them. And now I need to talk to you about your paper project. I will be posting a sample of the paper I want you to write. This is not going to be hard. It's already pretty much developed. What you have to do is take the format from the example that I'm putting up, and I'm going to give you some data about Instagram. And so what you're going to be doing is putting together a proposal. This proposal will be a study of a game, a conducible game, based on Instagram. And I want you to flesh out this report based on the structure that I'm giving you as to how you would go about getting this information and what you would do with the results and how you would analyze those results when it came back to learn from those results something about conducible behavior and in regards to Instagram. This has always been a group project in the past. I don't want it to be a group project this time because you're all scattered and it isn't very hard. So what I want you to do is take what you learned from the city certification experience, and then take the example that of the report that I want you to write, take the data and develop this out into a written proposal. We're not going to perform it. You're just going to get it written, ready to go. So if we had time in the future, we could conduct a study and analyze the results based on how you would analyze them if we actually conducted the study. And this is a big chunk of your grades, so you need to get on it right away and make it happen. Now, I have 2 more lectures to do before the end of the semester on topics that will be on the final exam, and I'll be posting those up in the next couple of days. So get going on this project right away. Don't sit on it because it's a big deal. And we'll move on to the next project.